Our second pattern is loss of a leaving group. And this is also something we saw in that original example. So let's say you have this species containing the halogen. When a leaving group is lost, what's essentially happening is if I highlight this bond here, and I'm also going to go ahead and draw in my lone pairs on the bromine, we can show these electrons leaving the carbon and going on to the bromine. Now in other cases, this has been forced by adding a nucleophile, but that's not to say this group can't just leave on its own. So if it leaves the carbon and goes onto the bromine as a lone pair, we end up with a positive charge on the carbon plus a new lone pair on the bromine and a negative charge. This is really just the opposite of the nucleophilic attack. In the nucleophilic attack, you would be doing the reverse reaction where a lone pair attacks the electrophilic carbon to give you the product. Let's look at one more example here. Let's say we have this. Right, in this case, I want to assume you're starting to get a feel for lone pairs, so I'm not going to draw in the lone pairs. What I'm going to do is kind of treat this negative charge here as a surrogate for the lone pair. And what we can do is push these electrons down to form a pi bond. That puts pressure on this carbon here because it can't have 5 bonds. So at the same time, I'm going to push those electrons away from the carbon and onto the chlorine as a new lone pair. So if we track our electron flow, we form a double bond to the oxygen that still has the hydrogen attached. And then we have Cl with its new lone pair getting a negative charge. Again, we do have charge balance. -1 in the reactants, -1 in the products.